All right, so we're going to have our next little piece of this is I'm going to talk about why this sort of makes sense. But first, I want to talk about a function. Now, we will recall from our glory days in basic algebra, if I say f of x is equal to, let's say, 5, then that's a horizontal function at 5. If I say f of x is equal to 25, that's a horizontal line at 5, and so on. So I may choose any value I like. I'm going to call this L. Let L be any number. For now, I'm going to assume that L is bigger than 0. It turns out you don't need that assumption, but for now, I'm going to assume L is bigger than 0. All right? And I want to compute the integral of L. Remember, this is a constant. The variable of this function is x, so that's why we're at dx is the variable indicator. So when you reattach the variable to the constant, this tells you what variable to reattach. And now I need the limits of integration. Let's suppose we go from 0 to another, it could be, for now I'm going to assume it's a number greater than 0, just like before. Later we will relax that restriction. But for now, let's assume this is a positive number. It could be 5, it could be 4, it could be 27, it could be 19. I'm going to assume it's just some unspecified positive number. I'm just going to call it W. So let's just assume L is the constant function. This is f of x is a constant function at L. And this is the integral from 0 to W of that function. And for now, we're assuming L and W are positive numbers. The question is, what computation, if we evaluate this interval, or this integral rather, what do we actually compute? Well, we know this. This is find antiderivative, so reattach the variable, and then evaluate that from lower limit to upper limit. So that's evaluate at the top minus evaluate at the bottom. Now, how do you evaluate? You take the upper limit of integration and substitute it for the variable. Then you take the lower limit of integration, substitute it for the variable. Remember, x is the variable, L is a constant. You treat L as if it were a 5 or a 20 or a 6 or something. So evaluate at the top, this is L times W, and then evaluate at the bottom, that's L times 0. That falls out, this is L times W. We think, okay, big whoopee, so what? What's all that all about? If we draw the picture of what we just did, it becomes, I think it's clear, it becomes significant. Because this is the constant function at L, that distance is L. And this starts at 0 and goes to W. That distance is W. And since we evaluated a definite integral, we just found the area under this curve, above the x-axis, and between these two vertical lines. We just found the area of a generic rectangle. The area of a rectangle is given by length times width. Now you're thinking, I knew that all along. Actually, you didn't. You assumed it all along. You need to be careful. There's a correct way to see this, and there's a wrong way to see it. The wrong way is this. Here's the wrong way. Oh, look, the calculus matches what I knew to be true. That's the wrong way to look at it. It is not correct to say the calculus is correct because it matches the geometry. It's the other way around. The area of this region is that. When we say area, we mean that. Now, the area of the region, the calculus says this is the area. Oh, by the way, what you have been using all along matches it. But it's not accurate to say this is correct because it matches that. No, it's the other way around. The reason this is correct is because it matches this. This is the bedrock upon which this formula is built, not the other way around. The calculus, anytime you use the word area, that's what that word means. And so we developed here the area formula for a rectangle. We could do the same thing for the area formula for a triangle, or for a parallelogram, or for a circle. We could develop all those formulas, and the reason they would work out is not because the calculus matches the stuff you've been doing, the geometry. No, it's the reason it matches is because the calculus is correct, and the geometry is built upon that foundation. This is the basis, and then this follows from it, not the other way around.